Welcome to Brain Vision.
So given the wave function here and the fact that the total energy is zero, we're going to start with the Schrodinger equation and proceed as follows. We're going to get the first derivative of the wave function. And that's going to have two terms. We're going to take the derivative of the first factor, which is x, and that gives us a times e to the minus x squared over L squared. And then we're going to have a second term which arises from the derivative of the exponential. And this gives us negative 2a x squared over L squared e to the minus x squared over L squared. Now we take derivative of this, which is the second derivative. So we'll end up with three terms. So we just take derivative of the exponential, and now we have negative 2ax over L squared times the exponential e to the minus x squared over L squared. And now we'll have a derivative of the second term here, which when we take a derivative of x squared, we have minus 4ax over L squared times the exponential. And now we'll take a derivative of just the exponential, and we end up with positive 4ax cubed over L to the fourth times the exponential e to the minus x squared over L squared. So we can actually combine the first two terms, and this gives us minus 6ax over L squared times the exponential e to the minus x squared over L squared. And the last term is still just 4ax cubed over L to the fourth. That's a 4. And then we have e to the minus x squared over L squared. And we can rearrange this a little bit. You'll see that in doing so, we have minus 6 e, actually, what I'm trying to do is just get ax e to the minus x squared over L squared right here, because this is the wave function. So we have minus 6 over L squared, and then here we have plus 4 x squared over L to the fourth. So yes, we have now the way that we want this to be factored, and this is the second derivative. So now we can substitute this into the Schrodinger equation, and we have negative h bar squared over 2m, and I'm just going to directly substitute, and we have negative 6 over L squared plus 4x squared over L to the fourth times ax e to the minus x squared over L squared plus u of x times ax e to the minus x squared over L squared. And this is going to equal 0 because remember the total energy E was equal to 0. So looking at this, we see that the energy, or rather the potential, is right here. The wave function is here, and the wave function is also right here. So we can identify this as the negative of the potential function. So this is negative u of x in order to have cancellation and have 0 on the right-hand side. So that means that u of x is equal to h bar squared over 2m negative 6 L squared plus 4x squared over L to the fourth. And you can go ahead and rewrite this if you like as h bar squared over 2m L squared 4x squared over L squared minus 6. Now, we can obtain a plot of this, and I do have an illustration of that, which I will pull up.